Okay, this is part 4 of this section on using Laplace transform on networks. Try these. Questions 1 and 2 will appear, the solutions to questions 1 and 2 will appear a bit later on in this video, and then you could have a look at questions 3 and 4, which are a bit more involved, and they will be solved on later videos. You could also look in the handout you got on Laplace transforms on page 1, questions numbers 1 to 3, and questions 9 to 11, page 23, extension questions, questions 4 to 8. And again, the solutions to those will appear on later videos. All that leaves us now to look at is when we put inductors and capacitors in a circuit and the effect that has, and that will be for the next group of videos. So looking at question number 1, let's have a look at the solution to this one, having had a go at it. Just be careful with this, of course. It's the same as the procedure we looked at before. We just got to be a little bit careful with the units and take our time over them. So number 1 solution follows. So this will give us that we've got the ES, as it's a step voltage, is going to be just 12 over S, and ZS is going to equal the resistance, which is 3 kilo ohms, plus 6 millihenries is 0.006 S. So now we plug those into Ohm's law. IS equals 12 over S over 3000 plus 0.006 S equals 12 over S into 3000 plus 0.006 S. And now we would use partial fractions, separate that out, and get 2 terms. So 12 over S into 3000 plus 0.006 S equals some term involving a constant and S, and a term 3000 plus 0.006 S. Cross multiplying, equating numerators, we get that 12 equals A 3000 plus 0.006 S plus BS. Equating coefficients, we get that, or multiplying out and then equating coefficients, we get that 3000 A plus 0.006 AS plus BS equals 12. Collecting together terms involving S, we get 0.006 A plus B S plus 3000A equals 12. And now we can equate coefficients, and we can say that 3000A equals 12. And that 0.006A plus B must equal 0. And that leads us to being able to solve for A and B. We get that A equals 0.004, or 4 times 10 to the minus 3, and B equals 24 times 10 to the minus 6. Now we plug these values of A back in, and we've got our 2 terms that we can transform back. Of course, I should have had that B equals minus 24 times 10 to the minus 6. And putting them back in, we get that IS equals 0.004 over F minus 24 times 10 to the minus 6 over 3000 plus 0.006 S. So now I need to get S on its own, because that's how they are in the table transform. So divide each term, top and bottom, in the second fraction by 0.006, and that will give us s on its own, which gives us this for is, 0.004 over s minus 0.004 over 500,000 plus s. Now we can use the Laplace transforms to find out what I is in terms of t. Minus e to the minus, or 0.004, e to the minus 500,000 t. Now I can take 0.004 outside the bracket, leaving 1 minus e to the minus 500,000 t. If I look at this solution in autograph, we see that it's an exponential growth to a limit, which hopefully you expected to see. But the limit is 0.004 amps in this case, so it arrives at a steady current of 0.004 amps, which you might have been able to predict. And also, the factor that t being as large as 500,000 means that the transient period is very small. As t increases, it doesn't take long at all before this exponentially decays, or this exponential decay part of it rapidly decreases. So about 10 microseconds is all it takes for this circuit to settle down to its steady state. Looking at number 2, we've got a 6-volt step voltage across a capacitor and a resistor in series. So again, the procedure is as we saw in the previous videos. So E S will just be 6 over S, and ZS this time is going to be 2 times 10 to the minus, or 3 times 10 to the 6, plus 1 over 2 times 10 to the minus 6s. Putting these into Ohm's law gives us that is equals 6 over s over 3 times 10 to the 6 plus 1 over 2 times 10 to the minus 6s. Bringing the s down means that is equals 6 over s into 3 times 10 to the 6 plus 1 over 2 times 10 to the minus 6s. Multiplying out the bracket to the bottom, we get 6 over 3 times 10 to the 6s plus 1 over 2 times 10 to the minus 6. So all we need to do now is just to get s on its own, so divide both or all terms, top and bottom, in this fraction by 3 times 10 to the 6, and you'll get s on its own. This gives the is equals 2 times 10 to the minus 6 over s plus 0.167. Remember that if I'm going to divide this term here by 3 times 10 to the 6, we've effectively got 1 over 2 times 10 to the minus 6 times 3 times 10 to the 6. When we multiply numbers, we add the powers, so minus 6 plus 6 is nothing, so we end up with 1 over 2 times 3, which is 6, which is 0.167. So it turns out to be quite a straightforward number at the end. And now we can do the transform back using the tables. So we get that IT equals 2 times 10 to the minus 6 times e to the minus 0.167 t. So plotting the graph at the end using autograph, we see that we start off with a current of 2 times 10 to the minus 6 amps, which you might have been able to predict. and then it decays exponentially, and it looks as though it takes around about 30 seconds for this current to decay to about 0. Now you might want to have a look at the next couple of questions, and the video solutions occur later on.